Hi students, I am Shivanarayana, physical science teacher from Krishnarao Pailam. How are you? Are you ready to listen today's lesson? Okay. Before we are going to discuss today's lesson, I want to quote one quotation from Einstein. Einstein quotation I want to read. I have no special talents. I am only passionately curious. From Einstein quotation once again, I have no special talents. I am only passionately curious. That is the great scientist statement. We are also, we had no special talents, but we have passionately curious. Okay? Now, I want to start today's session from these topics. Uh, these are the topics today we are going to discuss. First one is from heat, specific heat capacity, or simply say specific heat and its applications. Units of specific heat capacity. Specific heat capacity is different for different substances. And last one is one assignment is there, that is also home assignment. Okay, start. Activity 5 from your textbook. Please open your textbook, page number 5. Specific heat capacity. Simply say specific heat. Specific means particular. Already we know heat. Heat is a form of energy. It transfers from hotter body to colder body. So today we are going to discuss about specific heat. Heat is different from specific heat. So heat is only hotter body to colder body. That's enough. So today specific heat, particular heat. So here one figure is there. You have to observe this figure. Take a large jar with water and heat up to 80 degrees Celsius. Once again, take a large jar with water and heat it up to 80 degrees Celsius. Now take two identical boiling test tubes with single hold cocks. One of them is filled with 50 gram of water and other with 50 gram of oil. Once again, in right side tube it is filled with 50 gram of water and left side tube filled with 50 gram of oil, both at room temperature. Okay. Now insert two thermometers through holes of the cocks, one each into two test tubes. Once again, insert two thermometers through holes of the cocks, one each into two test tubes. Now clamp them to a retard stand and place them in a jar of hot water. Okay. Now observe the readings of thermometer every 3 minutes from oil tube and water tube. Note the readings in your notebook. Okay. What you observe? In which test tube does the temperature rise quickly? Once again, in which test tube does the temperature rise quickly? Yes, oil tube. Okay. Are the amounts of heat given to the water and oil is same? Yes, same, because oil is 50 gram of oil and water is also 50 gram of water. Yes. How can you assume this? Now, we believe that the same amount of heat is supplied to water and oil because they are kept in the jar of hot water for the same interval of time. We observe that the rate of rise in temperature of the oil is higher than that of the rise in temperature of the water. Okay, once again, what we observe in this experiment or activity, the rate of rise in temperature of the oil is higher than that of the rise in temperature of the water. Okay, why does this happen? Because oil is speedily temperature rises, but water is slowly temperature rises. Why does this happen? We conclude that the rate of rise in temperature depends on the nature of the substance. Okay, we conclude that the rate of rise in temperature depends on the nature of the substance. This is about specific heat. And also, next activity, activity 6 from your textbook, please open that page, 6th page number 6, activity 6. Here, two diagrams or two beakers are there. Are you observed? So two thermometers, different thermometers are kept in two different beakers. Okay. Now take two beakers of equal volume and take 250 grams of water in one beaker, that is left side beaker, and 1 kg of water in another beaker, that is right side beaker. Once again, in left both volumes are same, beaker's volumes are same. In left side beaker we take 250 grams of water, and right side beaker 1 kg, that means 1000 grams of water, take it. Note down their initial temperatures using a thermometer. Take a thermometer and put in the two beakers. First one is left side beaker, put in that and write down the temperature reading. And now put the thermometer in right side beaker, take the thermometer reading. Observe it and write down that. Now heat both beakers till the temperature of water in the two beakers rises at 60 degrees Celsius. Left side beaker and right side beaker, you have to increase the temperature up to 60 degrees Celsius. Now note down the heating times required to raise the temperature of water to 60 degrees Celsius in each beaker. In first beaker, left side beaker, give the temperature up to 60 degrees Celsius. Write down the time, how much time taken to raise the temperature up to 60 degrees Celsius. And also in right side beaker also, give the temperature up to 60 degrees Celsius. Write down the time taken. Okay. Which beaker needed more time? Which beaker needed more time? Yes, right side beaker is taken more time. Why? The quantity of substance, that is water, is more compared with the left side beaker. Very good. Yes, because in right side beaker 1 kg of water, that is 1000 grams of water, is more compared with the left side beaker, because in left side beaker 250 grams of water is there. The amount of substance is more in right side beaker and is less in left side beaker. Very good. Now you will notice that you need more time to raise the temperature of 1 kg of water when compared to 250 grams of water. That means you need to supply more heat energy to greater quantity of water than lesser quantity of water for same change in temperature. Okay, here one condition, one main point is there, same change in temperature. From the above experiment, what we understood or what we conclude, so here the amount of heat energy let us consider as Q, and mass of the substance is small m. Okay, Q is the amount of heat and m is the mass of the temperature, and delta T is the m is the mass and delta T is the temperature. So there are three factors. One is Q, another one is m, and another one is delta T. Now from the above experiment, the amount of heat energy is directly proportional to mass of the given substance where temperature is constant. When we consider two beakers and different substances, 250 gram of water and 1000 gram of water, then we consider a thermometer is put in the two beakers. We read when we consider take readings, same temperatures, initial stage same temperature, that's why delta T is constant. Okay, are you understood? Once again, Q proportional M, amount of heat energy is proportional to mass of the given substance. Here delta T is the constant. Why delta T is the constant? Because at the initial stage both temperatures are same. After heating, the temperature changes, but mass of the given substance is constant. That's why I consider second equation, that is Q directly proportional to delta T. From initial stage, Q directly proportional M, temperature is constant. And second one, when we given the heat to the both beakers, then the temperature changes. That's why we can write Q directly proportional to delta T, where M is constant. That is equation number 2. From equations 1 and 2, Q proportional M into delta T. When proportional removes, Q is equal to M into S into delta T. That is the equation number 3. So once again, Q is equal to Ms delta T. In some books, MC delta T also written. Whatever you write, Ms delta T or MC delta T. Therefore, S is equal to Q upon M delta T. Q upon M delta T or Q by M delta T. Here S is what? Specific heat or specific heat capacity. Q is what? Amount of heat or amount of heat absorbed. M is equal to mass of the given substance. Delta T is equal to temperature difference. Okay. So this is the main about the specific heat. Are you understood? From activity 5, what we understood? Oil and water are two substances are there, two different substances are there. So the temperature is, when we give the temperature is same, but which one is rises? Oil is rises more compared with water. From activity 6, so mass of the substance is changes, then only temperature is constant, and temperature is changes, mass is constant. So this is the specific heat about that. Okay, now so from the equation 3, S is equal to Q by M into delta T. S is equal to Q by M into delta T. Q by M delta T. Okay. Now, so from that equation, we give a statement, specific heat statement or definition. So here Q upon M into delta T. So let us consider M is unit of mass, delta T is 1 degree centigrade, Q is amount of heat of substance. So the statement is given like that. The specific heat of a substance, the specific heat of a substance is the amount of heat required to raise the temperature of unit of mass of the substance by 1 degree centigrade. Okay, once again, the specific heat of a substance is the amount of heat required, that is Q, raise the temperature of unit of mass, that is delta T, by 1 degree centigrade, by 1 degree centigrade. This is the definition. S is equal to Q by M into delta T. Okay, this is about specific heat. Okay, from this equation we can write units also. In physics, so units is more important. Okay, right. In SI units, so according that above equation, Q is amount of heat energy. In SI system, Q is joule. Mass of the substance is kilogram. Temperature is Kelvin. Okay, three units are there: joule, kg, Kelvin. Joule, kg, Kelvin. So from the above equation, S is equal to Q replaced by joule upon M replaced by kg and delta T replaced by Kelvin. So the total SI unit is joule per kg Kelvin. Very good. In CGS, similarly like that, Q is, in CGS Q is calories, M is gram, delta T is degree centigrade or degree Celsius. So from the above equation, so here write that calorie per gram Kelvin, calorie per gram Kelvin. So 1 calorie is equal to 4.186 joule. Already last session we discussed. 1 calorie is equal to 4.186 joule, approximately 4.2 joule. Okay, next 1 calorie per gram degree Celsius is equal to 1 kilocalorie per kg Kelvin. Okay, that is equal to 4.186 into 1 calorie. Kilo means 10 cube, 1000. 4.186 into 10 cube joule per kg Kelvin. Okay, specific heat and units is over. Now very important concept, applications of specific heat in our daily life. So here four applications are there. One is here, first one is see in figure, one ocean are there. Okay, so one ocean, the oceans behave like heat storehouses for the earth. The sun delivers a large amount of energy to the earth daily. Already we know that. The water sources on the earth, particularly the oceans, absorb this energy for maintaining a relatively constant temperature. Then the ocean behave like heat storehouses for the earth. They can absorb large amounts of heat at the equator with appreciable rise in temperature due to high specific heat of water. Therefore, oceans moderate the surrounding temperature near the equator. Ocean water transport the heat away from the equator to areas closer to the north and south poles. This transported heat helps moderate the climates in parts of the earth that are far from the equator. So this is also one of the main application of specific heat. Are you observing here one watermelon? Yes, very beautiful watermelon is there. Watermelon is also one of the application of specific heat. Watermelon brought out from the refrigerator retains its coolness for a longer time than any other fruit because it contains a large percentage of water. water has greater specific heat compared with all substances. Water has greater specific heat compared with all substances. Okay, second one is over. Third one is samosa, very eatable, very nice. Okay, samosa. A samosa is also one of the application of specific heat. A samosa appears to be a cool outside, yes, but it is hot when we eat it. When we eat it, why? Because the curry inside the samosa contains different ingredients with higher specific heats. Onions are there, carrot pieces are there, banana pieces are there. I think different ingredients are there. That's why they have higher specific heats. Okay, next one, fourth one, radiator. Water is used as coolant in radiators also. Sometimes radiators are break up when heat is more, then the radiators also broken. That's why water is used as coolant in radiators also. These are the applications of specific heat. Okay, right. Now again come to the back, what we discuss from activity 5, specific heat capacity. So here consider two substances. In left side oil beaker and right side water beaker. When heated is up, so when the temperature increases, oil temperature is more compared with the water. Here from activity 6 we observe same volume of containers, but the mass of the substance is here 250 grams and here 1000 grams, that is 1 kg. So what we conclude here, the amount of heat is directly proportional to m, where delta T is constant, and the amount of heat is directly proportional to delta T. Conclude that S is equal to Q by m delta T. From the above equation, we can write simply SI units and CGS units. Here one beautiful definition is there according this statement. The specific heat of a substance is the amount of heat required to raise the temperature of unit of mass up to what? 1 degree Celsius. This is the condition. This is the condition. Okay, from 1 degree Celsius to raise the temperature up to what? Only 1 degree Celsius. So unit of mass, that is also condition. Okay, applications, how many applications are there? 4. Very good. One is oceans behaves like a storehouses for the earth. Second one is watermelon is very cool. Very good. And third one is samosa. Samosa ingredients are very heavy specific heat compared with the outer surface of the samosa. Next one, fourth one is what? Radiators. Radiators sometimes broken. That's why water is used as coolant in radiators, because water has more specific heat. Here one table is there. Please try to observe this. One table is there. So specific heat for the value of specific heat for different substances. Are you observed? Here 12 substances are there. 12 substances. One is lead, mercury, brass, zinc, copper, iron, glass, aluminum, kerosene oil, ice, water and sea water. What you observe? Here 3 boxes are round up there. So please try to observe from bottom to top. Water. Water specific heat is in CGS 1. In SI 4180. Ice 0.5. In SI 2100. So please see, lead 0.031. 0.031. So here ice is 0.5 CGS, water is 1. Which one is high? Water. Very good. Water is the more specific heat and ice is 0.5. Lead is 0.031. Please try to observe in this table which one is more, which one is less. Which one is more? Water has more specific heat. Which one is less? Lead. Very good. Okay. Now I want to conclude from these questions. I want to give home assignment. Please write down this. First question is define specific heat. Mention its SI units and CGS units. Second question is write any two applications of specific heat in our daily life. Third question is which substance is more specific heat and less specific heat. And fourth one is one of the important question in coming classes. In future we have to go as an engineer or a doctor when the physics questions are raised like this question. Please try to understand. Very simple question. A copper block of mass is 500 gram and specific heat is 0.1 calorie per gram degree Celsius is heated from 30 degrees Celsius to 290 degrees Celsius. Then what is the thermal capacity of the block? I want to give a small hint also. Delta Q is equal to ms delta T, where m is equal to 500 grams. Simple. S is equal to 0.1 calorie per gram degree Celsius and delta T and temperature difference. You know ma? Delta T is temperature difference. Temperature difference means higher temperature minus lower temperature. 290 degrees Celsius minus 30 degrees Celsius. Then we can calculate, please. On next session, we will discuss the same concept, that is specific heat, that is principle of calorimetry and determination of specific heat of a solid. We will meet again. Until then, please try to write down in your notebook and important points, read it one or two times. Okay, bye.